Next, I would like to show you the implementation of a simple morphing box in Stiff. This morphing box is also a trilinear interpolation. Okay, the goal also is again to generate grids like shown over here, and you know already how we have generated that by blending. Refer to the previous video. And what you would like to do now is just to modify the shape of this grid in space by applying a morphing box. That is works as following. So we select all those elements and nodes which we would like to put into the morphing box. Then we take our cursor and go in the background of our view here and scroll down here in our scroll down menu to morphing box. We can take it on here because still there's nothing on, or generate a new one simply because there is none yet. So and that is already the result of it. So you see indicated here in color, apricot, all those nodes and elements which are now member of this morphing box, and you see in white, the outer size of this morphing box. What we can do now is that we can now just take any of these nodes and move these nodes in space, and what you see here is that we are generating in this case a bilinear interpolation, a hyper type of shape, simply by moving nodes which are members of the morphing box. Now to lift here this node here on this edge here, or this corner, I just pick it here, select it, we see it here or there, and we can now move it also around, and here we are, and we have just at once generated this hyper shape. Where we just needed some few more actions along the blending technique. That's it. You can take off the blending, the morphing box again with the cursor into the background of your view. You scroll down to morphing box off, and there it's now off. You can turn it on again, again by going down to morphing box on and off, and you are back into this morphing box where you had been before. If you would like to create a new morphing box, it's like the following. We take it off here, and then again we take some elements. We have selected some nodes in particular, these items which really generate shape. And with these new selected elements and nodes, we can now create a new morphing box. And you have been asked if you really would like to do that. If no, then of course you're back to what you had before. Nothing happened. Can we take it off? And I'll show you what will be the case if we just take something else. So for instance this here, just we take the morphing box on. We confirm here, and now we see again the orange or apricot elements are those which are now put into the morphing box, and you see nicely here in the perspective view how this morphing box is now arranged. It's now obviously a three-dimensional morphing box because our elements just are distributed in space. And again, we can morph everything what is inside the morphing box simply by picking any of the nodes which are inside the morphing box, and we just are able now to morph what we see. And again, that's a bilinear interpolation. It seems curvy simply because that is not aligned to the straight edge. This outer edge, and because of that, through the interior of this three-linear morphing box, so we have non-linear lines, and that's exactly what you see. But by that we are able to generate nice shapes if we like. Or let's look at this point here. Wow, isn't it nice? So we have now created something else. Again, and do last action. We come back to where we had been before, and we can take off the morphing box, or we can put everything else what we generated before in a morphing box, and by that we can again generate nice new shapes by selecting a node and moving around. And again, you see we also receive curved lines here, simply because this original straight line, yeah, which was not aligned to an edge here, so something in between. And as a consequence, you see it also here, yeah, after applying the transformation, we receive also something curved. But basically, we cannot do we cannot do more than negative curved surfaces by this implementation of the morphing box here in Stiff. Yeah, it's intended to be an educational program, a software, and not a commercial one, but still I think it's quite impressive what we are able to do. Thanks.